Hello everyone. So today topic we are going to discuss is smart cities and smart homes. So the goal of the smart cities and smart homes is development of IoT environment over smart cities and homes. We already understand in the previous lessons what is the goal of Internet of Things and IoT devices and these all things. We discussed the concept of cloud computing and fog computing, etc. So today we are going to discuss some points regarding the smart homes and smart cities. So what is the basic thing? What is a smart city? Smart city is the collection of different types of resources available in the city. So the resources will be used by the public. So the first point is an urban system. Simply, the city is made up of a group of schools, colleges, hospitals, and government, etc. All other departments. So it uses the information communication technologies, ICT, information communication technologies. Smart city will use and makes the infrastructure more interactive and accessible and efficient. So in the case of smart city, why should we go for smart city? So need for smart city. So let us go for that. So the need for smart city is rapidly growing the urban population and fast depleting of natural resources, the changing an environment and the climate. These all situation. So lots and lots of now IoT devices nowadays used. So these devices are getting the data, sensing the data, and giving the information to the subscribed users. So in the case of smart city also, so there is huge amount of ICT tools, IVCT devices was used for the purpose of making the smart city. So what is that? So if you see here, so if you see there are lots of different components that was there in the smart city. So that is waste management, transport, airways, schools, police, railway, hospitals, banks, etc. So there are so many components or major elements in smart cities. That is if you take any one of the element in the smart city, let us say schools. So school is connected to the waste management. That means the government is going to be collect the waste material from the school, and school is related to hospital. That means school is interacted with hospital. If you take, so because if any person, any school children is he was having some health problem, then he or she must can contact the hospital, and the health condition of the child will be monitored by the parent. And schools are having the collection of fees and other collection of like fees, and all the things are interacted with banks. If any issues comes in schools, so they are interacted with police department. And we need different types of transport, like police uses the airways, transports, services, railways. Transport is going to be sent the goods, exporting and importing the goods to different areas. So that means if you see in this particular smart city, there are different types of elements. Each element may be interacted with one another. So nowadays there are different types of IoT tools or IoT devices. So that is used by different components of the cities for the purpose of the smart. For example, they having the IoT devices with embedded software is there. The students is going to interact with the hospitals, and students is collecting their fees receipts from the banks using a single software. Nowadays there are different types of ERP softwares that was provided by different organizations and industries. So smart city, in the case of smart city, there are different types of elements was there. Each element is interacted with each other. And if you see the analogy of the software, if you take the two things, one human and the one was smart cities. So in the case of human, the what is the basic skeleton for the human? Skeleton, we need a skeleton, basic skeleton, then skin, then organs was the major parts of the human. Similarly, if you go for a smart city, so buildings, industries, and people is like a skeleton compared to human in the smart cities. And the skin is the transportation and logistics. The transportation means the data that was transferred from one place to another place. So logistics, nothing but the goods service that was transporting from one place to another place. And come for organs, like if you take organs in human, it is same like similarly like in smart cities we have hospitals, police, banks. These all major elements in the smart cities are like an organs. And if you consider brain is the one of the major part in the human. Similarly, in the case of smart cities, uh, like embedded intelligence, ambiguously embedded intelligence. So that means AI tools and other things was used like a brain in smart cities. And what is the nervous system? The digital communication through networks. Nowadays, every person is using the smart devices, smartphones, and these all things. So, smartphones and computers consisting of the software, all the people are using, they want to communicate using the telecommunication. So, similarly, in the humans, a human having the nerve system. In the smart cities, there was digital communications, digital telecommunication networks. And in the concept of human sensory organs like sensors and tags in the smart cities, sensory organs like nose, mouth, these are mouth, eye, ears, consisting of some sensory organs in the human. Similarly, smart cities consisting of sensors and RFID tags and like tags. And cognition in the human is exactly equal to the software. So it is just an analogy. Sometimes if you want to describe the smart cities is compared to the human parts consisting of skeleton, skin, organs. Similarly, smart cities consisting of buildings, industry, people, like transportation, logistics, hospital, police, banks, and other smart city elements we discussed. So please go through this. And we have next we have the applications and focus area of the smart cities and homes. So what is the basic application focus areas of the smart cities and homes? The smart economy, so that leads to competitiveness, and smart governance that leads to citizen participations, smart people that leads to social and human capitals, smart mobility that means transport and ICT tools, smart environment that leads to natural resources, smart living, quality of life. These all are the focus areas of applications where smart city applications. So let us discuss one by one. The first thing here is smart economy. If you take the global connection of different elements in smart economy, so like global MNCs are government agencies, worldwide buyers, public sectors buyers like this startup companies, indigenous diaspora, venture capital like this. For example, every time the smart cities, some for example, if venture capital was taken by government agencies or any private agencies, so they they give some area, or they are maintaining some real estate works. In venture capitals, they invest some amount regarding the smart city, and that was combined or embedded with the other important elements. Like this, it is the part of like venture capital, that is the part of global MNCs, government agencies, founders, etc. There are different types of elements in the smart city can be equipped, can be using that type of smart economy. Simply I will set the example. For example, any venture capital, any particular private sector have take some startup business. So the business consisting of the business having the marketing, and the business consisting of some capital employment, then these all things is related to different parts. So that leads to give the economy through the software. So that is the smart economy. And next, the smart governance, how the governance was established. So, smart governance means the cash transaction, the money transactions that was transferred to the different places based on their works. So, in the smart governance in a smart city can be involved of different elements like banking, government agencies. Government agencies was interacted with banking. They are providing finance, maybe government agencies, including the officials and citizens. Citizens will take the finance from government agencies, and government agencies will provides the reforms, safety, surveillance, and different managements. And it is also gives the public services, emergency services, like this, to the people. So that's why, so it is nothing but the governance management of smart governance through the software. Next, we have smart people. So smart people means who will subscribe to a certain service. So that will be there in the cloud. For example, in the case of education, the education consisting of colleges and schools, colleges, the parents of the children will subscribe to a particular service, like they want to monitor his children. So the children, if the children is suffered from any health problem, the healthcare will take care. And what is the status of his school or college fees will be dealt by banks, like this. So all the people having different types of modules that was connected in a single point or single IoT devices they want to use, like banking, shopping, transport, social networks, current affairs, safety, media, and these all things will be having different types of apps that was there nowadays. And some of free services and some of the paid services was there regarding different types of concepts, like nowadays different types of services was provided by the public clouds and private clouds, and and home heterogeneous clouds, like this. And this is regarding the smart people and smart mobility. We know that mobility is nothing but, so there is the reliability of data. So that means the data coming whenever the moving objects are it is coming wherever you are, so that the exact data, the reliable data coming from a place, without what is that, uh, without duplication of data. So that is regarding in smart mobility. There was in cities the logistics or transportation. The transportation is done through railways or airways, electrical vehicles, vehicle network, traffic controls. These all are the part of the smart mobility. Cities like localities, the population are uses different types of goods transformation because they want that. So for example, really the commodities coming from various areas, so they want to every day they want to see the monitoring of groceries, etc., through transportation. So that is also one of the good example. Railways, airways, these all things, vehicle network. For example, take any nowadays, so many people are using some apps like Wala cabs, and so what is the status of a particular vehicle, where is that particular vehicle, and everything is using some apps, and everything is maintained. So not only the transportation of people from one place to another place, it may be the logistics also. For example, if you buy any product from Amazon or Flipkart, you can have the logistic monitoring. That means tracking your product and all the things will be available in the smart devices. Smart environment. So smart environment is also consisting of various elements, like in the case of localities, and localities we have a government agencies and the population. There are different government agencies provides various types of software apps, so that is based on water management and waste disposal, and agriculture, and forest monitoring, population monitoring, disaster management, and green construction, and smart energy, etc. So that means like water management, every day we are seeing the water management, how much amount of water will be given to a particular house or particular flat in the city, and uh, what is the price you are paying to the government agencies or the private agencies who's dealing with that particular water management. If anything, any problem with your environmental problems, or you have a lots of waste is there in your home, you can call to that particular waste disposal department, so they will come and collect the waste. And the agricultural area also, so they want to find how much amount of crops was developed in this particular area, and these all things was maintained and monitored by the government agencies. And nowadays the people are also smart. They are using different types of smart environmental services. So that may be a forest monitoring consisting of, so they want to provide protect the wild animals, and what is the count of wild animals that will be there in the forest monitor. Population monitor, how much of population was there in the city, what it was reduced or increased, what is the count of population. These all things was maintained in smart environment. These all things leads disaster management. In the concept of disaster management, when a particular disaster comes, or disaster may become can be tracked by certain smart devices or smart environmental tools. And next, in the smart living also, in the case of what we discussed till now, these all elements will be there, like water management, waste management, agriculture, Okay, energy management, so like means power supply management, e-health, weather updates. These all are the part of the smart living. Who subscribe? They may be free services will be provided by the cloud. So in the previous concept, we already understand like fog computing. In fog computing, so that is the intermediate layer between the cloud. So nowadays, if you take smart, every IoT devices will send the data to the fog, and we are getting the data from that particular fog computing or fog from fogging. Okay, so there are different things we already discussed it so many times. If you want to write the content, so please go through that. So this is also one of the concept, one of the elements of the smart living and current focus areas. So smartphones, homes. So what is the need of smart homes? In homes, we need health monitoring of a particular person, conservation of resources, example electricity bills, what is the status of the electricity, what is the status of the water, what is the status of the fuel, etc. With IoT devices we will manage these all things. And regarding security and safety of a particular person, that is the current focus areas. Nowadays we are seeing smart parking lots, that means auto rotating of vehicles to empty slots. That means automatically vehicles will move to the automatic parking slots. Auto charging for service provided, so that means whenever so you parked a particular vehicle in a parked area, automatically it was charged through that. Maybe we are nowadays using the Paytm, etc. Detection of vacant slots in the parking lot. So that means vacant slots in the parking lot is automatically produced nowadays. In India, lots of major cities, they are using this type of smart parking lots. Smart vehicles like assistance to drivers during bad weather or low visibility, like a vehicle automatically assist regarding weather and low visibility if fog was there, normal fog was there. Detection of bad drivers, patterns or driving under the influence of substances, auto alert generation during the crashes. These all things, self diagnostics, these all are the smart vehicles. And come to smart health, so low cost portable at home medical diagnosis kits and remote checkups and diagnosis, on body sensors for effortless and accurate health monitoring, auto alert generation in case of emergency, medical episodes, example heart attacks, surgeries, pollutions at calamity monitoring, so monitors for weather or man-made based calamities. So these all things, that means pollutions and calamity monitoring is also is a one of the applications. Smart energies, smart metering systems, smart energy allocations and distribution systems, smart agriculture, that means automatic detection of plant water stress, monitoring of crop health status, auto detection of crop infection, auto application of fertilizers and pesticides. These all things are the applications. And technological focus area, so those are the areas what we discussed where we required the smart homes and smart uh, cities. So what is the technological focus areas? So data collection, because every time you talk regarding smart, we are using some IoT devices that consisting of sensors. So data collection will be done through mobile devices, sensors, and architectures. And data transmission will be done through networks, different topologies, and radio signals or radio transmission. Data storage can be done using a local storage or data warehouses. That means fog computing or cloud computing. And data processing is done through fog computing. That means data cleaning, analysis, and prediction is all the things. What is the major technological focuses? That was a data collection, data transmission, data storage, and data processing. So these are the important things. Please go through that. Please understand the things. First and foremost thing, IoT challenges in smart cities. The challenges are security and privacy. That means exposure to attacks. Example, cross-site scripting, side channel, etc. So smart in smart cities. So there was an attacks in cross-site scripting and a side channel. That means whenever you are going in a vehicle, so we need security and privacy. So because the vehicles will use different types of IoT devices which transfers the data through to cloud, and it is getting the data from the cloud. Any attackers will attack. So we need to secure that data. And heterogeneity, so integration of varying hardware platforms and specifications. That means heterogeneous means different types of hardware platforms will be there with the different types of specifications. That means all will be integrated into a single unit. And integration of different radio specifications and integration of various software platforms. Academic according of varying user requirements like this. These all comes under heterogeneity. And so this is also one of the major challenge, because each and every device is using different configuration and different specifications. So if you integrate, then we must get the reliable and efficient data transmission. So it is also one of the IoT challenge in smart cities. And reliability, so reliability means whenever we are talking regarding mobility, so data transformation or data packet transmission must be done through routers or from the signal points. It must be get a proper data packet within a time. So device failures still the significant. And next we have some other challenges like large scale legal and social aspects of big data. So that means the large scale delay due to large scale deployments. That means lots and lots of IoT devices with equipped with a huge amount of hardware. So there was a delay during the transmission of data, or there was a delay in the mobility, and there was distribution of devices cannot be affect the monitoring task. That means no accurate data whenever monitoring of particular device. And come to legal and social aspects. Services based user provided information may be subject to the local or international laws. So like a legal social aspects is also very important whenever you go for the smart. It is also one of the challenges that was facing, like individuals and information consent required for using of humans as data sources, because nowadays so many people are using IoT devices, so they must consider the privacies. Sometimes there was lots of legal and social aspects will be considerable. Big data, so the transfer, storage, and maintenance of huge volumes of data. I already tell the huge lots and lots of amount of data that was stored in the cloud computing. That's why we taken the consideration of fog computing nowadays. Analytics on gigantic data volumes is processing intensive. So these all big data is also consideration, because lots and lots of unwanted data is also storing. So the unwanted data must be reduced. So it is a concept. It is also one of the challenge. So data fusion, what is a data fusion? Data fusion means enormous volume of data is produced periodically in smart city environment. So whenever you consider the smart city, so in the smart city, every organization, every different elements in smart city is using various IoT devices. These IoT devices is consisting of sensors and combination of actuators, which generates huge amount of data, volumes of data. So that was the challenge what we understand in the previous slide. Challenges including making the availability incoming of a large data volume price of and accurate. So that means one of the good example we already discussed, whenever the camera is continuously monitoring by the organizations, so the data is will be making the request to the cloud, and cloud provide the service through cloud only. We are getting the response and huge amount of data that was stored using different IoT devices. Quality of data precision and accuracy affects the quality of decision making in IoT enables smart cities. That means the quality must be there in the data precision and accuracy effects. Uh, and data fusion enables the optimum utilization and massive data gathered from multiple sources and across multiple platforms. So data fusion means, data fusion enables automatically whenever lots and lots of data that is coming from multiple resources. That is multiple resources means multiple IoT devices. So these all data will be gathered. So that is known as data fusion. And the challenges, what is the challenges here in the data fusion? So imperfection. So that means sometimes because of lots of data is unwantedly storing, so inaccurate or uncertainty of WSN sensor data. Ambiguity. So that means same data will be available in different places, or missing of data. Conflicts. Same sensor type of reports or different data in the same location. Alignment. So that means sensor data frames are converted in a single frame or prior to transmission. So that means sensor data frames are converted into single frame or prior to transmission. Uh, Trivial features. That means processing of trivial data features may bring down the accuracy of the whole system. So trivial data features may bring down because of the accuracy and processing of the whole system. Stages of data fusion. The stages was decision level, like um, ensemble of decisions, future level, fusion of important prior to decision making. So based on the decision making, proper information will be must be stored. Pixel level, that means fusion of information at the image device level itself. Signal level, that means fusion of information at the sensor node with the local network itself. Like this, there are different levels that may be decision level. Decision level means at the starting point, the based on the decision only the data will be stored with the accurate data. And future level means fusion of information is prior to the decision making, based on that particular decision only the future level information will be stored. And pixel level means the concept of capturing of images or continuous capturing of images. So there were lots of unwanted data will be there, so you will be avoid that particular data on the pixel level. And in the form of signal level means in the for whenever we are making the request and response, so what we are going to use, like a local networks or global networks, or which type of better transmission we are going to use. These all things are the stages of data fusion. And data fusion for autonomous vehicles, if you go for data fusion, for example, a car is if you take nowadays a real-time car, so it has a GPS tracking, so that was coming from the satellite and RGB camera. So the camera will captures the outside surroundings and sending the data to the cloud for different purposes. And the vehicle management in the vehicles, there are different tracking, road tracking, and road monitoring, vehicle monitoring. These all things was there because the vehicle was made it with the different types of IoT devices, which is continuously storing processing of data. Okay, so that leads to the data fusion in autonomous vehicles. Okay, smart parking. If you go for smart parking, we know that the shortness parking sets time of drivers. So whenever the parking, wherever the park, some drivers needs to parking such time, so it must be reduces based on the traffic congestion, and reduces the pollution by keeping unnecessary lingering vehicles off the road. That means pollution is going to be reduces, keeping because of keeping unnecessary lingering vehicles off on the road. So because of monitoring, and reduces the fuel consumption and cost, increases the urban mobility. Shortened parking search time results in more parking time and hence more revenue. That means parking search time must be in the results whenever they use a certain smart app, so they find very less searching time for the parking and results, cutting the park time and everything. Functional layers of this parking. So generally, what is the functional layers? That was information collection. This was the top layer, and system development and service dissemination. Dissemination. Okay, information collection means there are different types of, because if you go for an autonomous car, um, it consisting of various GPS tracking systems and various IoT devices which collects the proper information, monitoring from various clouds and various servers. System development means the software what they developed under the IoT devices. What is the purposes? There are different purposes of the software that was developed in the system. And service dimension, there are different types of services provided through that particular software what they developed. That means there are mainly three, whenever we consider the smart parking, there are three different layers. You must remember and write in the whenever anybody asks regarding smart parking, please remember these things. Let us elaborate. Information collection. So through generally the information collections are from sensors, parking meters, sensor networks, and crowd sensing. Crowd sensing means whenever the sensors, different types of sensors, GPS sensors is going to be retrieves the GPS locations. Parking meters is nothing but the information is getting from the parking meters. Sensor networks, there are various sensor networks will be there. Crowd sensing, these all things are the different types of sensors which collects the information. And system development means the software system, information management, e-parking, guidance, and data analysis. These all are the part of the software, so that was embedded with the IoT device. Next is service dimension. In service dimension, dynamic pricing strategies, infrastructure based information, infrastructure free information, parking choice, vehicular activities. That means services will be provided through cloud or different parts of the organizations or industries, which provides various service dimensions whenever we will go for the smart parking. Smart homes, we already understand regarding smartphones, infrastructure consisting of intelligence networking, device infrastructure, seamless integration of various devices using wired wireless technologies, allows ease of use for household systems. Simple, these are all the points I am reading. Please go through that. Creates a highly personalized and safe home space. Corporations seriously indulging in smart homes systems, Intel, Cisco, Google. These are the different corporations. They are taking they are making different types of smart home equipments. These are the smart homes infrastructure that consisting of uh, things. We already know that intelligence networking devices infrastructure consisting of automatic activities, sensor activities, like this. Okay, please go to the points. Smart home aspects. What is a smart home aspects? In smart home aspects, communication network infrastructure. So that means hands, home area network consisting of various types of IoT devices and different hardware parts. Intelligent control and management. Intelligent control and management is the another part, another aspect. And sensor networks, smart features and automatic response. So these all are the smart parts of the smart homes. Everyone knows in so many times we discussed it in the class regarding different parts. So go through that. Okay. Okay. uh, so in home area networks, hands home area, that is comes under home smart homes. Network containing within a home enables remote access and controls of devices and systems, provides the amalgamation of various systems within a home or such as security systems, home automation systems, personal media and communication, etc. Okay, so please go to the points.